Hello everyone, my name is Tanish Kohli and welcome to the last video of this series of Introduction to Python. So now uh, there is only one big topic left, that is functions. So functions are basically used to reuse the code. Let me just show you this by an example. Suppose we have to find volume of a cylinder. So the formula is height into pi into radius square. So what we have to do, we have to every time, provide a height, we have to every time provide radius and then calculate the volume and then print it. So this is its volume. Now imagine I have to calculate another volume. I have to write this much code again. I have to change height, I have to change radius, and this is a very simple code, but if the code would have been bigger, the problems would have been bigger. So what we do is that we define a block of code which when called should return us or print us the value that we want. So that is called a function. So how we define a function, we use the keyword def to define, then we write the name of function that we want to give it, then we pass the parameters, and then we you know write the code, and at the end we return whatever we want the answer to be. So here what is happening, let me just make it into one cell, and all right, now let's just run this cell line by line. Okay, so here are the variables are just getting initialized. I will just show you, even variables this time. So this was an example of previous cell. Now we are at the line where a function is getting defined. So now next when we don't go directly inside a function because the function isn't called. So now program knows that whenever something like cylinder volume with a height and a radius will be given, it has to go to this part and run whatever is inside it. So now we have called cylinder volume with height of 10 and radius of 3. Now what happens is that now it goes inside, and our variables are now changed as height is equals to 10, radius is equals to 3. Now pi is equals to 3.14159, and now it will return us height into pi into radius square. So that's it. But you can also see that it hasn't printed anything. So what we can do is that we can pass its value. Let's just take another cell. Let's just take define a variable volume is equals to cylinder volume 10 comma 3, and then let's just print volume. See, here is our answer, and if we have to change anything, we can just simply do 5 and then run it. See, no need to write code again and again, no need of changing the variables. It is so easy, and basically we are reusing our code, which is one of the best practices in any programming language. So yeah, that's how a function works. Now we are doing nothing else but using a function to do different functions. All right, so we have defined another function called population density, which takes parameters population and land area and return us population divided by land area. So our test one is population density 10 by 1, expected result is 10, and then we print expected result using our format string. It will print out our expected result, and then it will print actual result as test1, this variable. Similarly, test2, a little bit more complex data is given. Let's just run this, and here is our answer. So what we can also do in a program is that we can return multiple values. Like here, we are doing sum and subtraction. We have defined a function, sum subtraction, which has two variables, a and b. And when this is called, c is a function, c is a variable that stores its sum, and d is a variable that takes difference, that means subtraction, and then we return c and d. Now the c and d values are stored in x and y respectively. Let me just run this as well as this and show you the output of x is equals to 8. If I put y, here is 2, so that is also correct. So we can, not just pass two variables, but multiple variables. We can return multiple variables, and they are really very useful. So this is just some function, and what it is telling us that, let me tell you with another cell. So what we are going to do, we are just going to call some function, and then, you know, some function dot word. I don't know, this shouldn't work. Yes, this doesn't works. So what we can do here is that we can use, same variable names to define multiple. All right, 3 2 1. So what we have done here is that we have some function that uses a variable word, and then we have another function that uses the same variable name word. But when some function is called, word is having different value, and when other function is called, word is having different value. So this is something that we can do, without wasting much space, and you know, it these are ethics of programming, and they are considered good practices. So now, suppose we have to buy bananas, and bananas at home count is equals to 0. So we have to buy. So we are defining a function buy, which takes the function count, the variable count, and then returns us count plus 12. That means we have purchased a dozen. So we just define count is equals to 0, and then we return print count. That gives us 12. That means we have bought a dozen of bananas more. Suppose we have 5 bananas, and now we are having 17 bananas because we just bought a dozen of bananas. So now what we are going to study is called lambda functions. Whenever I say Python is an interactive programming language, there are hundreds of things to prove that it is very interactive programming language, and lambda is just one of the best possible thing that Python has. So let's just make a function that multiplies x and y and returns us x and y. So to you know we just created a function, and now to call it, what we have to do, we have to define a variable multiply, or what we can also do is that we can simply print and then call multiply, and then multiply 5 comma, let's say 4. So answer is 20. Whatever it returned, it just printed it out. But what we can do in lambda is that we can replace this definition part and directly use this lambda function, where lambda x is what we supply. That means lambda x and lambda y are given by us, and x multiplied by y is what the program returns us. So let's just write a program to find squares. So all right, okay, I need to go to the back. Yep. So squares is equals to, let's use lambda function, and we will be passing x only as our variable. All right, lambda, lambda, we will be passing x only. So what after this, whatever we want to return, we will be using it. X multiply by x, or x basically raised to power 2 will be our output. So what we do, we square 10. Square 10 is 100. Correct. What else we can do? We can also pass this lambda function in a for loop. So what it will do, it will just run 10 times and give us a list of all the numbers with their squares inside a list, whatever we want to do. So now we are having cities as a list, and what we are doing is that we are making them selecting the cities whose name length is less than 10 characters. So New York City's length is definitely not 10. It is 3, 4, 4, 8, 4, 12, and 13. Let's just see. Okay. And okay, so length of, okay, nope, New York City. Let's just copy this. All right, I could have written it faster. 13. Yeah, that's our answer. Whereas if we see length of Chicago, it is smaller than New York City and even less than 10. It is only 7 characters long. So what we want to store this in another list called short cities and filter them based on this condition of cities. So let's just run this code line by line. All right, now the cities is initialized. Now such cities, that is also a list, is initialized, and it will be running for 1, 2, 3, 4, 5, 6 times. 2, 3, 4, 5, 6, and now just a false condition. All right, I again miscalculated it, or maybe, come on, now it is completed. Now we have Chicago, Denver, and Boston as our cities. So why it actually took this long is also something that you would like to know. It is because of this filter function, and it is also converting this into a list. So that means whenever we had an answer, that means Chicago, it was appending it into this list as well at the same time. So that is why it was taking this long. Now we are having a function called myRange, which takes a parameter x, I is equals to 0 while I is less than x, yield I, and I plus is equals to 1 for x in my range 5, print x. So let's just run this program first uh, for the first time. So what will happen? The function location will be stored. Now we will go into the for loop, and we will, for x in my range 5, print whatever the value of x is returned by it. So I is equals to 0 while I is less than equals to x. This condition is correct for the moment. Yield I. Okay, so this is something new. Let me just tell you about this. Notice that instead of using return keyword, it uses yield. That allows function to return values one at a time and start where it left off each time it is called. The yield keyword is what differentiates generators from a typical function. What we are studying here is a generator. This isn't any normal function, because let me just run this. So we were in this line. Instead of going there, what it just did, it just passed its value into the next uh, proper key, proper code. Then what will happen? Again, we will go inside the for loop. So we are again inside the for loop. But instead of starting from I is equals to 0, where we will start from? We should start from here because it was yielded. Exactly. This was a pause button, and now we are just starting from exactly where we left. So again, yield I, Now it is 2 again, now it is 1, now again going to this place, now it is 2, and while I is less than x, yield it. That means print x will be executed, and similarly it will go for the fourth one as well. This taking a little bit of a time whenever I'm doing this thing line by line, but I will also run this code as a block and you will see it is faster. So now what we are having is that it is now 5. So 5 is not less than 5. This condition will be false now, and we will be out of this loop. See, let me just run this. It is fast, as I told you. Now, what we will study is a function called zip. What zip do is that it matches, uh, we are having two sets here, with we can also have list, we can also have tuples. So what is happening here is that S1, the first index, and S2, the first index, will be combined, and actually we haven't specified the order, so that is why it is taking random. This randomness is there. We can also specify its indexes and zip our output. So this is our output. If we run it again, it might change. It isn't changing. I have to restart the kernel and it will change. So now we are having integers. This is our list. We are having letters. This is our list. Floats. This is our list. And then we are zipping all of them together. So what we have, let's just run this: 1a 4.0, 2b 5.0, 3c 6.0. This is how it is running. And now again we are having letters and numbers, but see what is happening here. We are again using two variables and then zipping them as one, and then iterating with two variables in a for loop. uh, just an example of interactive Python. I just cannot stop myself from saying interactive Python after every 5 minutes, so I'm sorry for that, but please pardon me. I'm really sorry. And now we are doing the same thing with two dictionaries. For key1 and value1 and key2 and value1, we will be zipping dictionary1 items and dictionary2 items and then printing them together. Again, interactive Python. I just think so that I should rename our playlist as interactive Python at this moment, but let's just leave it. So pairs, we are using a list, actually a list that is having tuples in it. All right, let's just run this ABCD, correct output again. Now what we are doing is that actually seeing how uh, for loop takes values. So we are having a list called values ABCD, and now we are defining another variable called value. We can name it anything. When I was starting in Python, so I used to get confused with this thing, that why we are using for value in values. Can we use anything else? Yes, we can. This is just a variable, but it sounds pretty cool, for value in values. So print value, whatever the value is. And now let me also show this thing by, line by line. We are inside a for loop now, and it will print a, then it will again go to the for loop, check for the condition, then print b, again check for the condition, and then print c. Come on, print it. Yep, that's it. And similarly we are using range of length of values. What is our length of values? It is 3. For the range of 3, value is equals to value index, and then we are returning index as well as its value, somewhat similar to dictionary output. All right, another thing that I would like to show you is enumeration. For count comma values in enumerate values start from 0. All right, one example back. This one is better. better to start with. So we are again having two variables, count and value, in enumerate value. So what it is going to do, the count function is actually going to return us its indices, whereas the value function will return its value from values list. We can uh, use change the indexing that we are seeing by saying that let's just start from 5. Okay, I believe that values isn't initialized, and I haven't also taken the enumeration dictionary. Just a minute, it is taking way too long. So this is how it actually works, and I believe something went wrong with my interpreter or my environment. Let's just restart the kernel. Yes, restart the kernel. Kernel is restarted. Let's just go back to it, and where it is, enumerate values is not defined. Of course, we have to first define values, then we have to, that wasn't necessary, and now here it is. I don't know what went wrong that time. It might be my interpreter would have just crashed or something like that. So we are also having this function. We can also see this as a function. So what we are doing is that we are having seasons as our list. There are 4 seasons: summer, spring, fall, winter. And then we are defining my enumerate as sequence, and start is equals to 0, where n is equals to our start. And then what we are doing is that we are going inside a for loop and then yielding n an element and then doing n plus 1. So if we just run this, it will, my enumerate is not defined. I haven't even run this. Yep, run it, and now it is just showing us that the function is actually correct, that the function has actually generated something at this address. So what it is, let us just convert this thing into list, and here it is: 0 spring, 1 summer, 2 fall, and 3 winter. So what this program is doing, what enumerate function was doing, but we have written this and seeing that how it works. It is just a clever use of yield keyword. Okay, so this is also, we are just zipping 3 lists and printing them 1, 2, 3, and then we are enumerating and zipping them. That gives us 0, 1, 2, 3, their indices as well. What we can also do is that we can use iter tools. They are useful. The first is not defined. All right, let us just first define all the variables and run this cell again. Here it is, iter tools. We are iter counts. That means how many times the loop has iterated itself. This also comes very handy. There is one more last topic that is left, and it is called arrays and numpy. Basically just numpy. So that will be the last video of this playlist. Hope you guys have enjoyed till far. Thank you so very much for watching the videos.